Well, good afternoon, ladies and gentlemen. I'd like to welcome you to today's webinar where we're going to be talking about the architect, the civil engineer, and the land surveyor. My name is Jeff Moore. I'll be introducing myself a little bit more in a second. We're going to be talking today about how our group of professionals can work better together to make the architect hopefully more knowledgeable and make his or her job a little bit easier. Before we get going, my wife, when she saw the title of this presentation, she laughed. She says, "It sounds like a joke. The architect, a civil engineer, and a land surveyor walked into a bar." I just thought that was cute. I have to work on the punchline on that. But moving forward, again, my name is Jeff Moore, and I am a civil engineer. I own and the president of Greenwood and Moore. We are a land surveying and engineering firm located in Castro Valley, California. I have a bachelor's degree in civil engineering from Cal Poly in Pomona and a master's degree in civil engineering from UC Berkeley. I've been a licensed professional engineer since 1987, giving me somewhat more than 35 years providing experience in residential and commercial development. So some of today's key elements that we're going to be talking about, we're going to describe some common site design difficulties and how the architect can minimize them by effective communication with the civil engineering and land surveying team. We're going to be talking a lot about when communication is appropriate, and more importantly, how land surveyors and civil engineers can help the owner and the architect have a more successful project with hopefully less problems. So from a civil engineering perspective and a land surveying perspective, this is the typical relationship that we see. You know, very often the architect is the lead design consultant, sort of the big dog, as we would say here, and the civil engineer and land surveyor are oftentimes just members of the technical team. Very common for the civil engineer and land surveyor to work together from peer to peer, but also have lots of input with the architect depending upon his or her involvement. Again, the architect is responsible for making sure that the owner's vision is developed and is responsible for all the creative designs and the overall project. The civil engineer, of course, we take care of things such as roads and parking lots and grading and utility, while the land surveyor deals with, you know, typically surveying, boundary resolution, boundary issues, easements, construction, staking, etc. So some of the key points we're going to be talking about today is the relationship between the architect and the civil engineer regarding a couple of specific items. The area of utilities. We're all going to be talking about the area of stormwater control and the difference between stormwater control and stormwater treatment. I find that there's oftentimes some misunderstanding on what these two critical elements are. And the relationship between the architect and the land surveyor regarding different types of surveys. And again, there's oftentimes lots of confusion on what type of a survey is needed, what type of information is on a particular type of a survey. So we're going to shed the light on that and bring some clarity and hopefully some directions on how to better discuss these types of issues. And then overall, throughout the whole presentation, we're talking about how do you use the civil engineering and land surveyor as a tool? How do we contribute, and when is a good time to bring us into the picture? And we're going to be discussing some strategies regarding that matter. So the first thing we want to talk about is utilities. So just to put things in context, just to make sure we're all talking about the same thing, there's basic utilities I'm sure that all of you are familiar with, but there's some nuances from a civil engineering standpoint that are important. So for example, storm drains, most people are aware, you know, you get water and it goes into an inlet. No big deal. So what's so special about that? There are ways that we have to deal with the water, but it becomes more complicated if you're dealing with storm drain systems that deal with rivers or lakes or streams or oceans. And believe it or not, there's quite a few properties around the Bay Area that deal with this. And so it can be much more difficult and time consuming to deal with entitlements and approvals and design when you're dealing with some of the natural waterways. Sanitary sewer systems. Again, most of the time in the built out areas, you've got a municipal sanitary sewer system, but there are lots of properties around the Bay Area that still use septic systems. How does that get implemented into the site design? And how does the engineer and land surveyor contribute to that? Other utilities we often deal with are, you know, cable TV, fiber optics, Fiber optics is an interesting kind of a beast. It doesn't happen too often, but the thing you need to know about fiber optic lines is if you hit one or if you have one in your property, they're oftentimes encased by large chunks, of concrete. It can be quite an impediment and a barrier. So something just to be aware of in the back of your mind if you ever see a fiber optic line that, ooh, something special might be happening here. In regards to water lines, there's all sorts of water here in the Bay Area. We've got domestic water, fire water. Oftentimes they're different systems. They're water wells, and some municipalities deal with recycled water. And of course, there's electrical, power, and gas. Pretty straightforward. Really, the site-related issues on these are how do you fit everything into the space that you have, and that's really a lot of the civil engineer's responsibility too. All right, well, we've talked about utilities, so big deal. Utilities have been around forever. What's the problem? From a civil engineering standpoint, typically problems arise when the architect does not have the appropriate utility information at the appropriate time, resulting in what can be a disaster. That's really sort of the bottom line. You need to make sure you understand what you have and where it is, so you can have an effective design. Very simple in principle, oftentimes gets overlooked or it comes in at the wrong time, creating problems. So from a utility standpoint question, there's a few things that we all want to know. Well, what size are the utilities? What's there? How big are they? Where are they located horizontally and vertically? And the last one here is a real issue that oftentimes can really get missed. And are the existing utilities adequate to meet the needs of the project? Is there enough water? Is the sewer capacity adequate? Do you have to upgrade the storm drain system? And this is a particular problem that we're going to discuss. So when you're looking for utility information, where is it normally shown? Well, as you probably are aware, normally you're going to see portions of it located on a topographic survey provided by a land surveyor. But one of the issues I think that gets lost is that depending upon the surveying firm, utility information is not always shown. It has to be requested. And so if you want to know where manholes or utility information is in an adjacent street, you oftentimes have to request it. It's sort of like buying a car. You can buy the basic strippy version, but if you want to get air conditioning and you want to get GPS, you need to ask. And I think one of the problems that we've encountered in the past is simply architects perhaps or owners don't know that they would have to ask for this. They would just, hey, I thought it would be on there. What's the deal? So yes, knowing what to ask for is one thing we're going to talk about in this presentation also. So who is ultimately responsible for obtaining all the utility information? Is it the architect, the civil engineer, the land surveyor? Who does this? Well, typically on most projects, it starts with a land surveyor. Assuming that you've requested that utilities be included in your scope of work, the land surveyor will do basic visible utilities. They'll pick up manholes, valves, inlets, things that you can see. And if they're requested to, they'll do what's called dipping a utility. They'll pull off the manhole, they'll stick the rod down there, they'll measure how deep it is. They'll try to determine what size the inflow and outflow pipes are going to be. Once again, I'm sorry if I'm repeating myself, it needs to be requested. But that is information that is done by a land surveyor. And think of it this way, land surveyors measure things, they document things. They generally don't research things in the design realm because that's the responsibility of the civil engineer. So very often when we work on a project, we'll get a survey from a land surveyor that may have some utility information, may have none. Then it comes to us, and when we start to do the design work, we're going to want to know, where are the non-visible utilities at? What is the routing and routing of the water lines? Where does the sewer line go? What is the condition of the sewer line or the storm drain system? So that is generally the responsibility of the civil engineer. And by understanding how utility information is collected and displayed, the architect can better provide options to their client regarding this critical matter at the beginning of the project. So how is an architect or owner supposed to know what to ask for? I mean, that's not their day job. Typically you don't need to know the details. We recommend that the architect would simply need to understand that, we've got to get these utilities dialed in. They're very important. Let's bring in the surveyor. Let's get some feedback from the civil engineer right at the get-go when we're starting the project, probably during the preliminary design phase, to get the appropriate information, or at least to have a plan for when you're going to get them. Makes a lot of sense to pre-plan and to build that into your budget and into your time frame. So how do you find out the size and locations of utilities? How do you do it? Well, there's really there's three common methods. There's the record research. You just talk to local municipalities to get data. There's what's called non-destructive utility location. These are companies that provide various types of utility locations. It's a more high tech, we'll talk about in a second. And then there's something called destructive utility location, which is potholing. And there's reasons for, you might need some of these and you might need all of them, or you might need none of them. And there's reasons why you do this. So when you're locating invisible utilities, the first thing is the basic record research. We do this most of the time, and that's where we're going to contact, PG&E, the local municipality. We're going to try to do some reasonable research to see what we can find that's supposed to be underground. And it's hit and miss. Sometimes you get lucky and you get wonderful data, and other times, it's kind of like a wasteland. But you want to go ahead and go through that. And so if it's requested, we'll provide this type of research. Sometimes we're going to recommend that you go, a client or an architect, consider non-destructive utility locations. If you have no evidence from your records research, it's oftentimes prudent to try to locate them using things like ground penetrating radar, or they have magnetometers, or they have sound devices that can hear water going through pipes. So a lot of high technology that can be utilized to make sure you understand what utility issues might impact your project. We talked a little bit about potholing, or to dig or not to dig. Sometimes on projects, there are critical utilities where you just have to know. If you can't make this particular critical utility infrastructure installation, it might kill your project. And there are some that it's that sensitive. So, oftentimes on these critical ones, we want to make sure that the owner understands the risk associated with critical infrastructure. So we'll recommend potholing. And it's typically when you have a gravity system crossing something. But how do you pothole? Well, you don't get out there with backhoes or excavators and, tear up the street. Normally you use a vacuum truck, like is shown in this photograph. It's maybe an 8-inch diameter hole, and they stick a hose down there and they suck the dirt out of it. Then there's a big deep hole, and the surveyors come back in, and we put our survey a rod down the hole and measure everything. Now we have a 3-dimensional coordinate point. We know exactly where something is. Then the hole is filled up with dirt and capped. So this is another tool in the toolbox that oftentimes needs to be utilized. I had mentioned earlier the issue of adequacy of existing utility. And if there's one thing, if a civil engineer is going to have a nightmare, this is the type of things that we dream about. This is a real bad situation. You go through a project, you've been told that there's public utilities, there's water lines, there's sewer, and then wham bam at the end of the project, when the developer goes to get their utility permits, you determine that there's simply insufficient capacity. Well, how do you find that out? Well, only a local utility agency can actually make that determination. Typically, a consultant would not do that. And in order to get a utility agency to make an adequacy determination, you have to submit a formal application, oftentimes with complete design drawings and fees associated with that. And in a situation where many of our projects occur, an owner may not want to spend all this money at the beginning of a project. Typically, if a project is going through an entitlement process, some sort of a design review, or some sort of a subdivision or something like that, the project isn't a done deal until they get planning approval. And so they don't want to spend a lot of money at the beginning of a project. So we understand that, and so we're sensitive to our clients' costs, but you don't want to get hit, on at the back end of it. So what we will oftentimes do is do a risk assessment with the architect, suggest a timing for when this might be done, help them prepare a budget and contingency plans. If this happens, this could be there. We could go option A, option B. It helps the owner sleep better at night, knowing that they don't have to spend a lot of money at the beginning, but at least the team has considered it and has a strategy to deal with it. Very important issue. I talked about when should you locate utilities. At the beginning or after approvals by the local municipality, after permits have been issued. And like everything else in our design field, it depends. In a perfect world, if you could wave a magic wand, from our perspective, we'd say all utilities should be located at the very, very beginning of a project during the preliminary design phase. Well, some projects, you just simply don't need that. If they're super simple, the risk assessment might be that you can just wait till the end, not a big deal. Sometimes you're going to say, yeah, it's super critical, I'm going to want to do this. Other times you'll wait until you get your entitlements. The point of the matter is that as long as you have a plan and you understand the ramifications of the decisions, you're good to go. And that is a major part of what we do. And that's one of the things that is very often overlooked. Very often we're brought projects where entitlements are done, then the civil engineer is brought on board, sometimes in the land surveyor when we talk about some of these other issues, and we find out there's a big problem and it creates a problem for everybody. So the risks and consequences of missing a major utility. And this is, unfortunately, I've seen this happen over the years, more frequently than not, typically in projects that we're not working on because we've got a pretty good policy working with our customers and architectural team members on how to deal with this. But, you've got utilities that are not found on a survey. Biggest issue is, by far the biggest issue is you have a conflict between a gravity system and some sort of a fixed utility. You've got a sewer line or you've got a storm drain line or something, and you can't go over it, you can't go under it. Now what do you do? Really big problem. And the risks can be, very costly and delay the project. If you find this out during construction that you have to move a water main that takes 6 months, that's not going to make somebody happy. So some issues on utilities and some suggestions is you want to make sure that information is not always shown on a topo survey, so you want to ask. The exact scope of research and verification may not be known at the beginning. Civil engineer should walk you through this and help you develop a plan of attack. If you don't do the utility research, it can really, really create a problem. So you want to make sure you do a risk reward analysis, make sure that you've got a plan and justify delaying it. Sometimes it makes sense to delay it. You're going to do it eventually anyway. So oftentimes it makes more sense just to do it now versus having a change order, but that is to be negotiated and worked out as part of the team. Again, the civil engineer should provide input on all of these matters that we've talked about: the risk assessment, utility research, how to do it, when to do it. That is our day job. So our takeaway from this portion of it is that the utility locations must be requested by the architect or the owner. The surveyor deals with visible utilities. Civil engineer deals with non-visible utilities. Agencies are required to determine adequacy of utilities, and the risks and consequences can be severe if you don't get this right. So we're going to move on now to stormwater control and treatment. So why is this important? The biggest reason that an architect really should care about it is because it takes up a lot of area on the site design. And if you've got these infill sites, which is pretty much most of the Bay Area anymore, there's not a lot of spare sites, and you want to make sure that they're incorporated into the preliminary design at the beginning, so you don't have to do major rework. We spend a lot of time working with clients who come to us where we have to go ahead and help them walk through this on plans that have already been designed. So what's the difference between the two? Stormwater control, simply put, is just a method to slow down the rate of water leaving the site. That's really what it's for. It slows it down. And typically it's achieved by underground chambers, bioretention areas, or other types of devices that hold the water. So for example, in this slide, on the left-hand side are some underground chambers, and there's a lot of these. They're proprietary ones. There's pipes. There's all sorts of stuff that water flows into and fills up, and it takes time to fill these little underground structures up, and then the water trickles out through a smaller hole. Then that's how the water is controlled. Well, these things take up a lot of area, they're expensive to build, and you want to make sure you understand where they go and how big they are right from the get-go. The surface detention basins are also another way of dealing with this. It's the same thing, it's just they're on the surface, but it takes up a lot more space. Stormwater treatment. All right, we've talked about stormwater control. Well, stormwater treatment, most of you might know it as C3, the state required mandates for stormwater quality, and that's what this is. And that's a pre-treatment system of stormwater before it enters a stormwater system or creek. And think of it as, I think of getting the big chunks, bags and leaves and sticks and, large pollutants and styrofoam peanuts and all that big crud that you don't want going into the stormwater system hits these bioretention areas, and it's filtered through the soil medium before it goes into the creeks. So in essence, it's just a pre-treatment system. And these bioretention areas are probably the most common ways of dealing with it. And this is a project we did on the left. There's this bioretention when it was first built, looks kind of sparse and barren. A lot of people don't like these, owners particularly because of the aesthetics. They don't like the plant selections that have to be made in order to accommodate the high moisture content in the soil. But if you look on the right, over time, they can be very attractive and grow out, and if designed nicely. And then this is sort of a picture of one in construction where it illustrates how this thing works. So here in the background, there's a 12-inch gravel bed, and underneath it are these perforated pipes. And on top of it, you can see this nice, rich, dark, lush, loamy soil, and that's about 18 inches thick, and it sits on top of the soil and or the gravel, and water pours into these things and soaks down through it and gets collected into the stormwater system. So these are oftentimes on sites placed directly adjacent to structures like this picture here. And it's important that you know where they're going to go, because it can have a big impact on your structural foundation depths. Moisture infiltration and water infiltration into structures is a big issue. And so knowing where they go, how big they are, how to deal with all this stuff is one of the reasons why you want to make sure you understand this design concept right at the get-go. It's tough to add these after the fact. So when dealing with stormwater treatment, there's some magic numbers here. So 4%, that's a key number, and that's the minimum amount of water treatment area required. So if you have, it's 4% of whatever impervious area you're working on. So it's very easy to calculate. If for those architects who deal predominantly with single family residents, the good news is you're typically exempt from stormwater requirements. It's true there are some lower level water treatment issues that you have to do, but it's nowhere near like building these bioretention areas and things like that you do for a large subdivision or for commercial development. 5,000 square feet is an important number for commercial parking lots. That means full compliance. So why is this important? Why does an architect care? Well, if you do commercial projects and you're doing expansions to industrial buildings or anything commercial, and you remove and replace 5,000 square feet of asphalt and perhaps regrade it a little bit and maybe add a small addition, well, if you hit 5,000 square feet, you now have to have fully treated stormwater system. And it's not so hard for a new development because it'll be included in the design, but man, it's tough if you've got to come back in and put in a brand new bioretention system in an old site. Oftentimes there's no storm drain, the grades don't work, then you start ripping out other things and it honks up your ADA accessibility. It has a real domino effect. So we do a lot of designs in parking lots that are 4,900 square feet to avoid this. But if you can't, knowing how to solve it is a major part of your preliminary site design. 10,000 square feet for typical residential and commercial developments, it's just a higher threshold for things that are non-specifically parking lot. It's the same thing. If you're greater than 10,000 square feet, you got to treat it. 1 acre is another milestone for larger projects. If you have a project that disturbs an acre or more, you're dealing with full treatment and you're dealing with full control, something called hydromodification. The only thing you need to be aware about is that if it's an over an acre, just need to know that your civil engineer is dealing with this for you. You don't want to forget it because it's expensive to find out later. That is my mantra on this whole thing, is it's very expensive to get surprised by this stuff later. So the takeaway from the architect and civil engineer on the stormwater issues is that stormwater control controls the rate of water leaving the site, slows it down. Treatment treats it, pre-treatment, get the big chunks out before it hits the storm drain. You need to accommodate these in the preliminary design to make your life a lot smoother. The civil engineer should be responsible for helping you do that. So the architect and the land surveyor. Now, this is an interesting area of working with our architects, and there's a lot of confusion about different types of surveys, and where the confusion typically comes with the actual boundary. And I'm going to go into that in a little bit of detail here in a minute. So the type of surveys that many surveying firms will provide is a topographic survey. Well, that's kind of the meat and potatoes, bread and butter. Almost everybody's familiar with those. There's aerial and drone surveys now, topographic surveys with record boundaries. And the technology for aerial and drone surveys is amazing. Now we're getting into boundary surveys. And you'll note that I particularly entitled these boundary surveys because a topographic survey is not a boundary survey. Boundary surveys deal with the property lines. Where are they? A topographic survey deals with other things that we'll go over in a minute. And there's two different types of surveys, simple and complex, but we also do boundary adjustments. These are certain types of surveys or maps that deal with moving property lines. And there's also something called an American Land Title Association or an ALTA survey. And I'm going to kind of walk you through these quickly. Topographic survey. Okay, with a record boundary. What's up with that? Well, as you all probably know, a topographic survey really does two things. It's a scale drawing that graphically indicates visible surface features on a drawing. Houses, retaining walls, driveways, sidewalks, curb cuts, visible utilities, all pretty basic. And then there's the property line, the boundary that's shown on most topographic surveys. Well, this is called a record boundary. So what the heck is that? A record boundary is a compiled boundary from data only. So what that means is that what will normally happen is you want a topo survey, we talk to the owner, we get a preliminary title report that describes easements, and we'll get a copy of the deed. The deed describes the physical size of the property. It's 27 feet long or 300 feet wide or whatever. And it also ties it into some type of a control network. You imagine back in the 1800s, you'd have a survey that says my property starts at the big oak tree on the hill and goes 27 paces to the north. Well, that's tying it into some physical feature. We're a little more sophisticated these days. There are typically survey control monuments throughout the Bay Area. We locate those, and the surveyor graphically draws a picture of the boundary in the computer, and they tie it into the survey control networks, and they lay it over the topo, and they cross their fingers and hope everything, what I call, fits. So what does that mean? Well, the property line appears to be in line with fence line construction. It appears to be between buildings. It's not in the middle of a garage, or it's not 10 feet away from a fence. So sometimes, if it fits, there you go. You get a topographic survey with a record boundary, but it's not a boundary survey. And we'll get to that in a minute. This is what 99% of people need to do the development, is this type of a survey. You can do the same type of a thing with an aerial or a drone survey to do the measurements. And same thing with the record boundary. It's compiled. We'll just plop it onto an image that's taken from an aircraft or a drone. Okay, boundary surveys. So we get asked all the time, I want a boundary survey. Well, a boundary survey, I think the simplest way to place it is when most people want to know and see a physical marker. I want my corner staked. I want to see where the property line is. Okay, that's fine. If you do that, you have to file with the county a recorded map. If it's a simple project, you can file what's called a corner record. The surveyor will tell you whether it qualifies or not. And there are certain requirements in the MAP Act in the state of California that allows you to do this. This is an 8.5 by 11 sheet of paper. It's fairly simple and inexpensive to do, and it's a filed map. Great, no problem. Well, if you have a real problem with the boundary, and this happens, commercial developments, subdivisions, it doesn't matter. If you want to know where your property is and staked, you're going to file a record of survey. It's more expensive. It takes longer to get approved by the municipality, but this is the gold standard. If you've got a problem with your boundary, if you're having a dispute with your neighbor, there's an encroachment of your property that's discovered during the topographic survey in the record boundary, you'll get it resolved by filing a record of survey. Takeaway on this is that topo's doesn't give you stakes in the ground. You start marking properties, you get some sort of a recorded filed map called a boundary survey. A boundary adjustment, simple type of a map that just shows how property lines are moved around. Get these pretty frequently. Also, if you're going to merge parcels, it's done through a boundary adjustment. And so we do lots of boundary adjustment mergers in commercial development. So just to be aware of that. An ALTA survey it's a special type of a survey that's typically used for commercial refinancing. It's to make sure that a lender understands what's on a property. It's kind of a combination. It's a hybrid. It's not a boundary survey per se, nor is it a topographic survey. It's a site plan with a record boundary on it. The only thing you need to care about is that if an architect gets an ALTA survey and from an owner and gives it to the civil engineer or surveyor and says, hey, I've got my survey done, you probably don't. It's a lot of good information. It's certainly valuable, but you're not done with an ALTA survey. You'll probably need to augment it with a topographic survey. So the takeaway on this portion of it is that there are lots of different types of surveys. Topographic survey is the most common. Boundary surveys, simple and complex. Boundary adjustments, ALTA surveys. The key on here is to get with your land surveyor at the beginning. Let them guide you through the process. Then you can go ahead and make sure the owner is aware of the potential need for survey requirements. Doesn't come as a surprise. We can keep them updated throughout all along the way, and that way it just becomes a smoother process. So I'm kind of wrapping things up here on when you start a project, you're going to want to start with a topographic survey with a record boundary. You're going to want to request utilities to be placed on the topographic survey. Don't forget, you have to ask. A boundary survey might be required if there's a problem with the record boundary. If you want property staked, you just have to ask for it, understand the ramifications. When you're dealing with stormwater control or treatment, engage the civil engineer early in order to make sure that you've properly accounted for them in your gross site planning. Utility verification should be assessed at the beginning to determine if it's an issue or not. And if it is an issue, what's the plan of attack? How do you deal with it so it doesn't come as a negative surprise? And again, consider bringing the civil engineer and land surveyor as part of the team. And I would actually add the landscape architect much earlier than has often been done in the past. And so this is sort of a little checklist. I would say that if you take anything away from this particular presentation, it's just to know what questions to ask or what things your team members can do for you. Architects are responsible for a lot of moving parts on projects, and they don't have to remember the 4% rule or all the areas, but if they know that, gosh, there's some things I should deal with now, let's get them on the team, let's explain it to the owner, this is why it's justified. They can go through this little checklist and it's just determine what type of survey you need and start with the topo if you're not sure. And it's a little bit of a duplication of the previous slide, but it's something you can take with you and hopefully help you in your assessing your needs. So while I wrap this up, I want to go through just a couple of slides here on some illustrations of just some issues that come up and how that applies to this presentation. This is a project that's a large commercial project where there was an existing building, and this was an open pad, and the architect, very good architect, brought us the basic site plans, but stormwater control wasn't really accommodated for. There were no utility information, caused some delays, had to rework the site plan. Just caused a delay and some additional costs. This is a project that it's a church expansion, and the architect brought us on board along with the landscape architect at the beginning. This was our recommendation. They thought they had all this stuff wired because they had the complete as-built drawings of the original phase, but unfortunately, some of the rules had changed for the utilities, and they couldn't use what they wanted. And on this particular project, we were able to really help guide them and adjust their budget for their financing purposes right from the get-go before they got through their entitlements. Really saved a lot of hassle, and the client was very grateful for that. And I think the architect really led the charge on that by bringing the full team on board right at the beginning. This project is one in Berkeley that illustrates a project where we were working with just a top-notch architect, and we knew from the start that utilities were going to be a major issue. And you can see that this property is bordered by 2 streets on the side, and there's a railroad track and another street. So it's encompassed by old streets, very poor infrastructure. We went out there and we were very concerned that there was not going to be enough adequacy for the fire sprinkler systems without a complete major upgrade. And we tagged that right at the beginning, and the architect and the owner authorized a research portion of it to ensure that we understood where this was going. So it's something that got caught, and this would have been a disaster to find this out after all the entitlement work was done for this multi-phased commercial project. And this last one illustrates just a residential subdivision where the same thing, we had concerns about water capacity issues, and sure as shooting, we contacted East Bay Mud. Absolutely turned out to be there was a major problem. And so because it's at the beginning of the project design life cycle, the owner was able to understand the ramifications, budget accordingly for it. Now we're coming up with preliminary designs to make an application way ahead of time. We don't even have the entitlements for this project, but to understand how much is it going to cost to expand the water lines, and also ways to get neighbors perhaps to pay for it. Wow. So that is the end of my presentation on the exciting world of land surveying and some civil engineering stuff. And with that, I am happy to answer any questions that might be available here. Okay. Let's see. So I've gotten a couple of comments. So I have one that says, so land surveyors do not research for hidden utilities. In my experience, that is not the norm. So they will do visible utilities. I suppose it's possible to have a land surveyor out there who will do that, but it's generally been my experience that that is not the case. We have another comment that says, what does full treatment compliance entail? Well, that's a great question. So full treatment means you have to comply with the C3 stormwater control measures that are implemented by the local municipality in accordance with the state mandates. So what does that mean? So if you're doing a 10,000 square foot commercial remodel, that means you have to size the bioretention or treatment areas to the 4%. And you have to make sure that it's located in a way that the 10,000 square foot of area drains properly to it, and that it either controls the water flow. So you have to have all the details, and you have to fill out a stormwater control checklist that the municipality typically has. And that can be, these things can be 10 or 12 pages long. They can be quite complicated. So it's not just that you put this treatment device in there. It has to meet certain criteria, and you have to demonstrate that it's going to work. So that's what full compliance entails. It's a question says, is it always the case when getting a topo survey that the engineer will alert the owners to an encroachment? If there is one, say if a fence is built 5 inches off. So normally, yes, we would. In other words, we take a look at, we look for encroachments, we look for things that are unusual, and part of the service is that, yes, we would bring that up to a client and say, there appears to be an encroachment. What do you want to do about that? And so the answer is yes. You would expect your surveyor to notify you of things like that. Anything that's out of the ordinary would be expected to help walk you through that. Let's see. I have another question here. It says, during municipal review of a development, can an adjacent property owner require that the city require the developer provide boundary survey complex? Example, an existing 28-acre residential development, 8 buildings exists next to proposed multifamily residential development, 60 units on a 1 acre in Emeryville. So the question is, can a neighbor require it? I'd say indirectly. I happen to be an Alameda County Planning Commissioner too, and so it gives me a perspective on neighbor input on developments how I see many municipalities dealing with situations like this. So here's how I would answer that question. If neighbors are going to make a big enough of a stink and they can demonstrate any type of a reasonable rationale that, for example, the record boundary on a topographic survey is not adequate or is possibly an error, I am going to say that many municipalities are going to take the easy way out and say, fine, go ahead and do that. Now, can you fight that? Absolutely, you can. So what we would do in a situation like that, if we did the survey and then for the development and the neighbor came in and said, I just want you to do a boundary survey and it's going to cost you $50,000 to do it. Well, we're going to talk to the city or the municipality and say, you know, here's why we don't think that's fair. Here's how we compiled our boundary. Upon which basis are you going to make us do this? We would certainly fight for that and try to talk them out of it. But at the end of the day, it's the municipality's call on whether they're going to actually require that or not. So how can I get a civil engineering degree? That's cute. Oh, it's probably easier than an architect's degree. Yeah, that's good. Actually, and I think that is all of the questions that I have. Sydney, is there any, do we want to open this up? Yeah, and so are we hiring? Yes, we are. If you know of anybody who wants to be a land surveyor or a civil engineer looking for a job, please send them our way.
Yeah, if anyone else has any questions, feel free to either put them in chat or you can unmute yourself and speak to the group.
Okay. Well, it sounds like, oh, hold on a second. Right now, we have another one. It says, when do you recommend civil engineer involvement in a residential project? So the way I look at it is this: if you have any type of entitlements, any type of design review, I would suggest during the preliminary design phase, right from the get-go is my recommendation. If it's a simple, remodel that you're doing a room addition on the back and there's no special type of entitlements or planning department approvals, and it doesn't appear to be a complicated process, you can probably wait until after the conceptual plans are approved by the owner, but as soon as possible is always the better way to avoid problems. We had someone says, can I do a course with you as work experience? Absolutely. I think that'd be interesting to discuss. So you can always reach out to me on that. And I think that would be an interesting option. Okay. Well, seeing no more comments, I would just like to thank everybody for their participation. I was just honored and thrilled to be able to have this opportunity to talk for a little bit, and I really appreciate your presentation and participation. Thank you so much. Everyone have a wonderful day.
Thank you.
Thank you.